Welcome back, future educators. Let's take a look at some consequences of the Pythagorean theorem as it pertains to Euclidean geometry, to coordinate geometry. Specifically, let's pretend that you have some grid you're graphing on an XY grid. Here's your x-axis and your y-axis, and you have 2 points on the grid. You have maybe the point 1, 2, 1, 2, 3, 4. This point right here is 2, 4, and you have some other points over here. This point would be 2, 4, 6, 8, 2, and you want to know how far apart are those 2 points. Well, how do we figure out how far apart those 2 points are? The easiest way to figure out how far apart those 2 points are is to drop an altitude to this segment, make yourself a right triangle, and then figure out what this is, because you can do that by counting, and what this is, because you can do that by counting. And you can get this by the Pythagorean theorem. This is the distance that we want. So leg squared plus leg squared is thing that we want squared. So that's easy to do. So that distance is the square root of 40. The distance between 2 points on the coordinate grid, the length of this line segment on the coordinate grid, is a direct consequence of the Pythagorean theorem at work. Yeah, but what if we want to be generic? What if we want a generic point x1, y1, and a generic point x2, y2, and we want the length of that segment? What happens if we want the distance of a generic segment? Well, I argue that it's the same thing. It's exactly the same thing. We make a right triangle and we count. We count. Now it's generic, so we can't actually count, but it seems fairly straightforward to think, how far would this be vertically? It's from one y value down to another. It's from one y value down to another. And similarly going across, this horizontal distance goes from this x value to that x value, from that x value down to another. And so leg squared, leg squared plus leg squared is distance squared, which means that the familiar distance formula that you remember from high school is just the square root of this expression. It didn't fall from the sky. It wasn't given by divine revelation. The distance formula that you're familiar with from your early days comes from the Pythagorean theorem. The other consequence to look at in the coordinate grid is the equation of a circle. So let's pretend, shall we, that we have some circle and it's centered at the origin and maybe it's got radius 3. And we'd like to find the equation of the circle. This has a radius of 3, that's 3, that's 3, that's negative 3, that's negative 3. And we have some generic point on the circle. The generic point is xy. The center is nicely here at the origin, 0, 0. And so we wonder to ourselves, what describes, what relates, what is the relationship between x and y for all the xy's that are on that circle? And that answer is a little bit interesting, because for every point on the circle, we can drop a perpendicular and we can connect it to the origin, like so. And if we do that, we get ourselves a cute little right triangle. Well, who cares? Well, let's move the, oh, really? Let's move that out of the way. Let's put the origin back where it came from. Let's make the picture look decent for the YouTube public. How far is this distance? Well, this distance is the distance from x down to 0. And how far is this distance? Well, this distance is the distance from y down to 0. And how far is this distance right here? Well, that's the radius of the circle. So for any point x, y, we can make this right triangle. And so for any point x, y, leg squared plus leg, oh, in fact, let's do this in a better place. Leg squared plus leg squared is radius squared. And so you may have, I mean, there's nothing special about that 3. You may have learned that the general equation of a circle is x squared plus y squared is radius squared. You may have learned that if the circle is centered at the origin. But what if it's not? What if the circle is centered at 2, 4, 6, 6, 5, and has a radius of 4? What if the circle is centered at 6, 5, and has a radius of 4? What do we do in that scenario? What describes the xy's? Well, same game. Same game. You get a right triangle. And this distance is y minus 5, and this distance is x minus 6, and we play the same game. Leg squared plus leg squared is radius squared. And so you might have learned that if the center is some point hk and the radius is some number r, then the equation of the circle is x minus h squared plus y minus k squared equals r squared. But it didn't come by accident, it didn't fall from the sky, and it certainly didn't come by divine revelation. It came from the Pythagorean theorem applied to our circle. So the Pythagorean theorem has far-reaching consequences, and I am glad to show you a couple of them, and I'm sure that there will be more when we gather in class.